Okay, so the last video was number 8, describe two transformations for the image of A below. And so far what we did is we reflected it over the y-axis. So now we're going to take that new shape and the red one and make it so that it's A prime. So there's two ways to do it. You could slide it and do a translation, or you could flip it and do a reflection. I'm going to choose to do a translation, so I'm going to take this point and drop it onto this one so that they match up. And that would shift the figure down 1, 2, 3, 4, 5, 6. So that would be a translation. And the rule, so this is the first thing we did, and then the second thing is a translation taking XY point and it's down 6, so that would be on the Y, down 6, and the X, we didn't move left or right, so it stays just the same. And that is how you write it out. So the next one, number 10, I think it skips 9. Draw the final figure after rotation clockwise 90 about the origin, then translate, then reflect. So we got quite a few things to do with this one. So the first thing is rotate clockwise 90. So when we're rotating clockwise, let's see, the clock goes around like this to the right. Right, the tick hand moves like that. So I'm going to, and 90 degrees would be one turn clockwise. So I'm going to take my page and move it once to the right. Okay, so now I need to know what all of the points are after turning the shape once to the right. So let's see, T is still 0, 0, so I know I have 0, 0. We got Q. Q becomes, now it's on the y-axis now, looking at it turned, so that's 0, 2. If I want this, let's see, I've got point Y, and that's over 1, 2, 3, up 1, 2, 3, so 3, 3. And then point M is over 1, 2, up 1, 2, 3, so 2, 3. These are the points I need to graph after I turn my paper back straight. Okay, so now I'm going to graph those points. 0, 0, 0, 2, 3, 3, and 2, 3. Okay, so that is the rotated figure. Now it says translate using x minus 1, y minus 5. So that would take each point 1 to the left and then 5 units down. X numbers go side to side, so it's 1 left. Y's go up and down, so 5 down. So 1 left, 1, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. And the last one, 1, 1, 2, 3, 4, 5. Okay, so I've done the translation now. And last of all, reflect over y equals -1. Okay, so I got y equals -1 right here. And I don't know if I have quite enough room to, I better do it in another color to show my final shape. So the final shape, I'll make it in red. I want to reflect it over this line here. Y equals -1. That's this line. It's crossing the y-axis and it's on -1. And I want the points to be equidistant away from the line of reflection. So I go one up and I go one more up. One and then flip it over. This is 2 away, so I go 2 away right here. And then this is 1, 2, 3, 4. 1, 2, 3, 4. So my final shape is here. And if I were to name those points, the final points that would be given is 1, 0, 2, 0, -1, 1, and -1, 3. I know it didn't say to name the points, but that's what they would be. 11, draw the final figure after a reflection over y equals -x minus 2. Rotate 180 and then translate. So we're going to start with the reflection. And it's y equals -x minus 2. So I'm going to go down 2. And my slope is -1. So I go down 1 over 1. It's a perfect diagonal. Not through the origin, but it's a diagonal. And this is the line. And I'm going to count, if this diagonal is directly through each square, I'm going to count directly diagonal through each square to get there. So point E, notice, is 2 diagonals away, or it's a slope of 1 over 1, 1 over 1. So I'm going to do 2 diagonals again, or 1, 1, 1, 1 slope. Puts my new point there. Point I, that's an I. Point I, 1, 2 and a half. So I'm going to go half and then 1, 2 more. That's point I, and then point X, we're going to go 1 and a half, halfway, and then 1 square more. So that is our new triangle after the reflection there. So I'm going to get rid of this other stuff because it's really confusing after now that I need to, now that I need to do I'm messing this all up. Okay. Get rid of this green line. That's what I want to do. Okay. So that's the new shape after the reflection. Rotate 180. So I'm going to take the shape and rotate 180. Okay, so that means I take the full figure and I'm going to turn it upside down, or 180 is 1 turn, 2 turns. It doesn't matter with 180 which direction you go, because it's going to put it upside down anyway. So the points are now, I would go from the center, left 1, down 1. I would go left 1, down 2. And I would go right 1, down 2. And I'm going to turn it back straight. Then I'm going to graph those points that I listed out. So left 1, down 1. Left 1, down 2. And right 1, down 2. So that is the new shape. Flipped 180, rotated. Sorry, not flipped, turned 180. And then from there it says we want to translate it +2 for x. That means 2 to the right. And then we're not going to do the y at all. So it's just 2 squares to the right. So I'm going to put my final shape in a new color. We'll do green. So 1, 2, 1, 2, 1, 2. So the final shape is the green one. That is the one that would be the answer when you are done. Okay, number 12. List all degrees of rotational symmetry in a regular pentagon. A pentagon, think about the pentagon in Washington, that's 5 sides. And if I want degrees of rotation, I'm talking about how much do I turn it in the center and still have that same exact shape where the point is straight up and each of the other points is right where it is supposed to be. So if you look at this, we've got 1, 2, 3, 4, 5 angles. All the way around is 360, so I'm going to take 360 divided by 5. So the first turn I could make and get the same exact shape for rotational symmetry is 72 degrees. If I do that again, or if I do another 72 rotation, it's going to look the same, so that would be 144 degrees. Again, another rotation of 72 is 216. Another rotation is 288. And finally, I'm back to 360. And those are my 5 degrees of rotation for a pentagon. Which of the following transformations will result in a congruent figure? Congruent is same size, same shape. Mark all that apply. A dilation is going to make your shape bigger or smaller. A dilation is a stretch. So it is not a dilation. Stretch. Okay. A reflection will keep your shape the same exact size and the same shape. It's not going to change the size. A rotation, again, it's not going to change the size. It's just going to, not the shape either, it's just going to turn it. And a translation just slides the shape, and that is not going to change the size or shape. So that is all 3. You got B, C, and D. Okay, the next one. You want to prove that 2 triangles are congruent. You already have shown that angle C is congruent to F and side BC is congruent to EF. What else do you need to know to confirm that the triangles are congruent? So I would draw out 2 triangles. You can draw them however you want to. Okay, so I've got A, B, C is congruent to D, E, F. They need to go in that same order, D, E, F. We know right now that C angle is congruent to F angle. And we also know that side BC is congruent to side EF. So we have an angle and a side that are right next together. So what else do we need to show that they're congruent? So we have side angle. We could do another side. Or we could do angle, side, angle. So what we're missing a side for this. That would make it congruent. Or we're missing an angle. That would also make it congruent. So which side and which angle? If we need side, angle, side in that order, it would have to be side AC, congruent to side, side, angle, side. That would be DF. Okay, so this is what you could have, this one. Or we could have the angle. So I need to get rid of that.